Hey guys, this is just a short video to recap some of the big ideas from Module 1 to help prepare you for the Semester 1 final. So these are one of the big things we talked about in Module 1 was transformations. And so here's a generic function notation using a, h, and k to shift a function. So a provides a vertical stretch. I'm going to actually add or compression. Okay. H is a horizontal shift. Remember, this one is kind of opposite of what you would think. So when it's subtracting a number, it's moving right. When it's adding a number, it's moving left. And then K is a vertical shift. Adding moves a function up, and subtracting moves the function down. Okay, so we're going to do a transformation example here in a second. But one of the other things that we did in this unit was simplify expressions with exponents and radicals. So this is kind of a combination of a bunch of our exponent rules. I always like to work with what's in the parentheses first and simplify what I can, and then worry about this negative exponent afterwards. So I'm going to go through and I'm just going to reduce a term at a time. So 2 over 6, I could reduce that to 1/3. Okay? M's, so I have m to the 6th and m to the 4th. Whenever I'm dividing with powers, I'm going to subtract the exponents. So 6 minus 4 is 2, and my answer goes wherever the bigger exponent was. So you can think about it as 4 m's cancel with 4 of those m's, and so I'm left with 2 m's being multiplied, which is m squared. Okay, p to the negative 2. Okay, there's no other p's for me to combine. But I don't want to have any negative exponents in my final answer. So I'm going to put p to the 2nd on the bottom. Remember, when I switch a negative power to either the numerator or denominator, when I switch it, the sign changes to a positive exponent. And then n to the 0, anything to the 0 power is 1. I'm just going to write that in there so we remember that's what happened. Okay, so I simplified as much as I can in the parentheses. Now, I don't want my final answer to have a negative exponent. So remember, negative exponent, we flip things to make that exponent positive. So I'm going to flip this entire fraction, and I'm going to get rid of the 1's in that process too. So on the bottom, I have 3p squared. So that's now going to be my numerator. I have 1m squared on the numerator. That's now my denominator. And now that I flipped the fraction, my exponent is now a positive 3. Okay, so now to get rid of the parentheses, this exponent of 3 is going to be applied to every single factor within the parentheses. So I'm going to have 3 to the 3rd, and then p squared to the 3rd. When I already have an exponent and I raise it to another power, I'm going to multiply those exponents. So this becomes p to the 6th. And then same thing with my denominator, m squared to the 3rd. I multiply the 2 and the 3 to get m to the 6th. I can go ahead and go one more step because 3 to the 3rd is 27. So we've got 27p to the 6th over m to the 6th. That would be my most simplified answer. Why I know that is I don't have multiple p's or m's. They've all been condensed into one term. I don't have any negative exponents, and I can't reduce anything within this fraction. Okay. B, this is an exponent where I have a radical in the denominator. So actually, before I do this, I'm going to actually break down 18 first. So 18 is 9 times 2, and I could break 9 into 3 and 3. So I could rewrite this as 3 over, that pair of 3's comes out front, and that 2 stays underneath the radical. So the 3's right now, 3 divided by 3 is 1, so I could rewrite this as 1 over the square root of 2. So this is more simplified, but it's still not considered fully simplified because I have a square root in the denominator. To get rid of it, we rationalize. So I'm going to multiply both the top and the bottom by square root of 2, because that just means I'm multiplying this whole fraction by 1. So it's not changing the value, it's just changing how it looks. So 1 times the square root of 2 is square root of 2. Square root of 2 times square root of 2 is square root of 4, which is just 2. This would be my simplified radical expression. All right, now on to a graph example. We did a lot of domain and range in this unit as well. So domain, remember, is looking at our x values. What is the leftmost value and the rightmost value? So if I look at the leftmost value and the rightmost value that this graph goes, the x value here is -3, and the rightmost value it hits is 1. So this is where I'm going to use interval notation. I need to pay attention to, do I use a bracket or parenthesis? When it's an open circle, we're going to use a parenthesis. When it's a closed circle, we're going to use a bracket. Also something to remember, if we're using infinity or negative infinity, it is always a parenthesis with either of those. Range is low to high. So now let's look at our y values. What's the lowest value my graph hits and the highest value my graph hits? Okay, again, we're going to look at the y value. So the lowest y value my graph gets to is -4. The highest y value my graph gets to is 0. Okay, -4 has a point here and a filled in point here, so it is a bracket. 0, I do have a point here, but I have an open circle here. If that happens, remember the closed circle, the point always trumps the open circle. We actually do hit 0 at some point with this graph, so 0 is included in the range. Okay, now I'm asked to find f of -2. Remember, this is an x value. So they want to know what is the y value that goes with this x. Okay, so we're going to find where x is -2 and then look at what's the corresponding y value. So here's x is -2. The y value right here is -4. So -2 maps to -4. So f of -2 equals -4. Okay, here's a transformation one, kind of using that note we talked about at the beginning. It says, given the parent function f of x, some random function, describe the transformations on the parent function given by this equation. So f is just some function. We don't actually know what the original graph looks like. We're just going to describe how these different values shift the graph. Okay, so remember when we're describing this, we want to kind of work our way inside out. So I want to start with the parentheses. So what does that +1 do? Well, the first thing it's going to do to the function is it's going to move it, not right. Again, this is opposite of what you think. Adding is going to move us left 1. That's the first thing that's going to happen. Second thing, okay, so inside out, so I went to parentheses, then I'm going to go to multiplication. So I'm multiplying by -2. So there's kind of two things that are happening here. So we are going to vertically stretch by a factor of 2. And kind of simultaneously, that negative reflects over the x-axis. Okay, and then the last shift that we're going to have is addition or subtraction outside the parentheses, which is a vertical shift. -5 is going to move us down 5. So those are the different transformations that are happening to this graph. We know that without even looking at what the original graph looks like, just based on kind of this notation. We know that inside the parentheses, left or right, multiplying out front is a vertical stretch, and then addition or subtraction outside the parentheses is a vertical shift. Okay, that's all for the examples, you guys. Just a quick recap on some big ideas from Module 1.